Alright, so let's take a quick look at an equation that you're going to see a lot in algebra, and that's the quadratic equation. Quadratic equation. So what is a quadratic equation? Ultimately, x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by a 2a. Now, this is kind of a arbitrary equation, kind of out there, so the question is, how does this come to be? Well, the first thing to know is, what is the standard form for a quadratic equation? Standard form is going to be ax squared plus bx plus c is equal to 0. So the point there is, if you have a quadratic equation in this form, then we can solve for the variable x using this equation here. Now, how does the equation come to be? That's the point. Well, let's start trying to isolate x over here. So first off, I see a is multiplying by x squared there. So let's get rid of the a by dividing all our terms on both sides of the equation by a. So this will become x squared, since a divided by a is just 1. Then bx divided by a, well, I'm going to write that as b over ax for the time being. And then we'll have c over a, and then 0 divided by anything is just 0, so that just stays what it is. How fun. Now let's get rid of c over a by moving it to the right side by subtracting c over a on both sides of our equation. The result of that, x squared plus b over ax equals a negative c over a. Now, the left side of my equation, it looks like a quadratic equation, but we're missing some third term there, right? Well, there's going to be a particular value that's going to force the left side of our equation to become perfect square. The way we find that is by completing the square, and the nuts and bolts behind that, really, I'll go into a geometry video to explain the proof, essentially, as to why that works. But ultimately, what we need to do is just take that term b over a, and we're going to divide that by 2. Now remember, 2 is the same thing as 2 over 1. So here I have a fraction divided by a fraction, which is the same thing as b divided by 2a. Now, what we do with this quantity is we just square it as a whole. So that's going to give me b squared over 4a squared. But I want to make note of this term inside of here. We're going to remember that that's there. B squared over 4a squared, what I want to do is add that to both sides of the equation. So the left side of my equation is going to be x squared plus b over ax plus b squared over 4a squared equals, then I've added b squared over 4a squared to the right side of the equation, so we get that. Well, by force, I made the left side of my equation a perfect square. What perfect square is that going to be? Well, it just so happens it's going to be x. Here I have a positive b over 2a. That's going to be the term that's inside of there. Hence why I made note of it. So the left side, you can think about like origami. We just folded the left side over, and so it's a perfect square. X plus b over 2a, quantity squared. And then the right side of our equation, it's b squared over 4a squared. What I would like to have here, let's look at the right side. Specifically, we have two fractions with differing denominators. Well, the easiest way to get a common denominator in this case, notice we have 4a squared versus just an a. So if I multiply the right fraction by 4 over a, or 4a divided by 4a, then that's going to accomplish getting a common denominator of 4a squared. So I'll go ahead and write everything over that. But then I'll have b squared minus 4ac in the numerator. Cool. Almost there. See how it's kind of shaping up? Well, I'm trying to solve for x, and right now it's trapped by being squared at the moment. So what I'll need to do is take the square root of both sides of my equation. However, I need to be careful. I'm taking the square root of a squared quantity. Whenever you take the square root of a squared quantity, we need to remember we're going to have a positive and negative version. So on the left side, square root is going to cancel out the fact that we're squaring, so we'll just have x over b over 2a. And then on the right side, and this is where it kicks in, we need a plus or a minus on our square root. Because, for example, negative 3 squared is 9, and so is 3 squared. It's 9. So we need to get our positive and negative versions there. Finishing or filling out the rest of this equation here. Boom, boom, boom. Deal here on the right side, we can clean that up a little bit better, because the square root of a quotient being division, is the same thing as just the quotient of their individual square roots. So what I can do is write this as plus or minus the square root of b squared minus 4ac, because there's nothing I can really do with that. However, my denominator, that's going to be the same thing as the square root of 4a squared. I'm going to leave the plus or minus off because I'm going to simplify this. 4 is a perfect square. 2 squared is 4. A is a perfect square. A times A is A squared. Hence, our denominator is just going to be 2A. Numerator stays, then plus or minus square root of b squared minus 4ac. And then my right side is the x plus the b over 2a. We want to solve for x. That's what we want. What's wrong with it? It's got b over 2a too much. So let's subtract that off, leaving us with x equals a negative b over 2a plus or minus square root b squared minus 4ac, all divided by 2a. And then last but not least, we got the same denominator. So let's go ahead and just write it like what we're expecting to see. We've got 2a in our denominator, we've got our negative b plus or minus square root b squared minus 4ac, and that is exactly what x is equal to. So anytime we've got a quadratic equation in its standard form, hence the emphasis on that, getting it into ax squared plus bx plus c equals 0. If we've got that, boom, nothing more we got to do. We can just jump in and just use that quadratic equation.